Here are the video solutions for NOCN Functional Skills Maths Level 2, and this is Reform Sample Paper 1, and this is Part A, which is the non-calculator section. Okay, so looking at question number 1, we've got this, it all looks very confusing here because we've got the number in brackets and we've got a plus and a minus. We could just write that as 2, 4, 5, 6 plus minus 5, 6, 3, and a plus followed immediately by minus means minus. So first of all, just plus minus, turn it into minus. So that's what we need to do. So 2, 4, 5, 6, take away 5, 6, 3, just column subtraction now. 6 take away 3 is 3, 5 take away 6 can't be done, so 4 becomes a 3, the 5 becomes a 15, 15 take away 6 is 9, 3 take away 5 can't be done, but actually we can just do 23 take away 5 here, which is 18. So the answer is 1893. Okay, so we want to work out the coordinates of C, which is here. So we just need to remember that we go along the corridor and up the steps. So horizontal, then vertical. So we're going horizontally to 5, and then we are going down to -4. So the coordinates are 5 minus 4, and that is answer 2. Okay, so find the mode of this data. So we just need to remember that the mode is the most common, and there are a few we need to be careful of. So some are in grams, some are in kilos. So if I remember that 1 kilo is 1,000 grams, so I just need to divide 36400 divided by 1,000, and that is 36.4. So this is also 36.4 kilos, and this is 4.3 kilos. Okay, so let's take a look at the first one. 36.4 appears twice. So 36.4 kg times by 2. So they're gone. 54.2 only appears once, not the mode. 56 only appears once, not the mode. In fact, everything else just appears once. So the mode is therefore you can write it, I suppose, as either grams or kilos, but the mode is 36.4 kilos or 36,400 grams. So there we go, because it appears twice more than any other number. Okay, so this is it's a fairly tricky one for me. The problem is the graph paper. It's not obvious which lines are darker than others, which doesn't make it terribly easy to see, or maybe that's just my eyesight. So I've counted going across that there are 34 squares. So what I'm going to do is I'm going to say that the scale is that is 1 meter. Okay, so 2 squares is 1 meter. Okay, so if we've got 11.5 meters, that if I double that and I double that, then I can work out how many squares, and 11.5 times by 2, so that is 23 squares, 23 SQ by, and 15.75 times 2, that is 31.5 squares. So I'm going to count across. So I said there was 34 in total going across, so it's 33, 32, 31.5. So if I just draw a straight line to there, and we also want 23 squares going down, so let's just do another line, this time going down. Okay, so 2, 3, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20, I believe that is 23. Okay, so again, let's just do the same down this side as well. So that needs to, it's quite hard for me, ideally this line would be a tiny bit, oh there we go, that's perfect. And let's just connect them at the bottom as well. There we go, so I've got the outline. Probably a bit too long now. That'll do, that's fine. Okay, so right, what do we need to do next? We know that 2/3 is grass. So going across, we have 31.5 squares. So what is 2/3 of 31.5? Well, that is 31.5 divided by 3 multiplied by 2. So we're going to have to do some calculations here. How many 3's go into 31.5? So 1, 0, point, carry the 1, 15 divided by 3 is 5. 10.5 times 2, that is 21. So we want 21 squares across. So 2, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18, 20, 21. So if I drop a line down here, this separates the grass from the patio. So 2/3 is grass, so this is the grass section over here, and this is the patio. And it says he also wants a shed to be placed in any corner of the patio. So remember that 1 metre was 2 squares, so if I double these, that's going to be 7 squares by 2.25. If I double that, that's going to be, if I double the 2, I get 4, and I double the 0.25, I get 0.5. So 7 squares by 4.5 squares, and in any corner of the patio. So I'll just stick it down in this corner here. Actually, literally any corner will be fine. So in fact, I'll put it in this corner here because then I can just count whole numbers of squares. So it's 7. So 1, 2, 3, 4, 5, 6, 7. Actually, I'll just do this on freehand. 2, 4, 6, 7. I think that's 7. 1, 2, 3, 4, 5, 6, 7. And we're going up to 4.5. 1, 2, 3, 4.5. So 4.5 over there. So again, probably should use a ruler, of course. So that is the shed. Okay, and now that my scale isn't particularly clear anymore, so I'll just perhaps draw it a bit more clearly, that is 1 metre, and that is 1 metre. There we go, and we're done. Bit of a fiddle that one, but we got there in the end. Okay, so we want to work out 5, 6 plus 13 over 4. So I'm going to do cross multiplication. So 5 multiplied by 4 plus 6 multiplied by 13 all over 6 times 4. 5 times 4 is 20, plus 6 times 13, I might have to work that out using a column method. 18 carry 1, 1 6 is 6, plus 1 is 7, plus 78 over 6 times 4 is 24, so that is 98 over 24. Both are even, so I'll simplify that to 49 over 12, and I'll turn that into a mixed number. How many 12s go into 49? Well, 12 goes into 49 4 times. 4 12s are 48, so that is 1/12 left over. So there's my final answer, 4 and 1/12. Okay, so the house costs $1 million. So remember that $1 million is 1 with 6 zeros, and the deposit is 378500. Make sure you line the numbers up correctly, and they should be lined up from the right. Okay, so 0 minus 0 is 0, 0 minus 0 is still 0. Now we can't do 0 minus 5, so I need to borrow from the next column, but that's a 0, that's a 0, that's a 0, so I'm going to have to borrow from here. So this 1 will become a 0, this 0 becomes a 10. The 10 becomes a 9, and this 0 becomes a 10. This 10 becomes a 9, this 0 becomes a 10. This 10 becomes a 9, so that this 0 can become a 10, and 10 minus 5 is 5, 9 minus 8 is 1, 9 minus 7 is 2, 9 minus 3 is 6. So the answer is £621,500. Okay, moving on to question number 7. Calculate the area of a triangle where the height is 15 and the base is 7. So remember the formula for the area of a triangle is base times the height divided by 2. So that's 15 times by 7 divided by 2. So what is 15 multiplied by 7? 5 7s are 35, carry the 3, 1 times 7 is 7, plus 3 is 105. So we need to divide 105 by 2. 1 divided by 2, 0, move the 1 across. 10 divided by 2 is 5. 5 divided by 2 is 2 with a remainder of 1. Here we need to put in a decimal point and a 0, so I can park that remainder of 1 to make a 10. 10 divided by 2 is 5. So the answer here is 52.5, and we'll put in the units, which is square centimetres. Okay, what's the probability of picking a blue ball? Well, there are 5 blues out of a total of 16 plus 4 plus 5. 16 plus 4 is 20, plus 5 is 25. And we want to give our answer as a percentage. Well, a percentage is a fraction which is out of 100. Remember that percent means out of 100. So here we can see the number on the bottom has multiplied by 4. So for an equivalent fraction, we'll multiply the top by 4, and 4 times by 5 is 20. So that is 20%. It doesn't quite make sense here to 2 decimal places. So I guess I'll just put in 2 decimal places, 20.00. I think that must be a bit of a mistake there. Okay, and that is the end of part A. Here are the video solutions to NOCN Functional Skills Maths Level 2. This is Reform Sample Paper 1, and this is part B, which is the calculator section. Okay, so we're just comparing 2 lorries. We know straight away that lorry 1's got a capacity of 536 square feet. So we need to work out the capacity of lorry 2. So we can see from the picture that it's a cylinder, and we know it's a cylinder because you've got a length and a diameter. Also, it does say it's a cylinder, which helps. Okay, now the formula for the volume of a cylinder is like any other prism, any other sort of 3D shape with a constant cross section. It is, so here's the cylinder sort of turned, so it's standing up. It's the area of its face multiplied by its height or its depth. Now here the area of the face is a circle, and the formula for the area of the circle is pi r squared. So pi r squared multiplied by the height h is the, so this is the formula for the volume of a cylinder, which some people might just learn as a formula to learn, but this is how it's derived. Okay, so pi is 3.14. Now we know the diameter is 7.6, so if the diameter is 7.6, then the radius is 7.6 divided by 2, so 3.8. So 3.14 times 3.8 times 3.8 times the height of 19.35, and that comes to 877.35996, and that is feet cubed. So which lorry, which one's the bigger lorry? What's the one with the bigger capacity? So we're comparing 877 to 536. Okay, so no contest, it's lorry 2. This number here was so much bigger than this number here. It makes me suspect that I've got something wrong. Normally the values when you're comparing are often quite close, but I have double checked this answer and this is correct. So the answer here is lorry 2. Okay, so next question, question number 10. So her employer is going to increase the hours by 3, so and we want to calculate the percentage increase. Now the formula for a percentage increase or a percentage decrease is the difference divided by the original multiplied by 100. So we've got a difference of 3. It originally was 21. Okay, so 3 divided by 21 multiplied by 100, that comes to 14.28%, and we want to the nearest whole number, so we'll look at the first decimal place. It's a 2, so that will round down to 14%. Okay, question 11, we need to first of all plot these values on the graph. So let's just take a look at, so what I'm going to do here is, I think it makes sense to have arm span along the bottom, and I'm going to have height up the top. Now let's just have a look at our graph paper. So it's 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 14 across, and 2, 4, 6, 8, 10, 12, 15 up. Okay, right, so 15 up and what's it, 14 across. Okay, so we need to think about how we want to maximize the space in the graph paper here. So let's have a look at the lowest and the highest value for arm span. So the lowest is 121, the highest is 180, and 180 take away 121 is 59. So I want to go, I need 59. What is 59 divided by 14? 59 divided by 14 is 4.2. So it probably makes sense to go up in fives. So the arm span, we're going to go up in fives, and we're starting at 121. So we'll start at 120. So 120 going up in fives. So 130, 140, 150, 160, 170, 180. 190. So this is arm span, and this is in centimeters. So double check, I'm going from 120 to 190. Yeah, and that definitely includes my lowest and the highest value. There are other ways you can do the scale. I'm just trying to maximize the graph paper. Okay, so for the height, the minimum is anything smaller than 125. Nope. Anything bigger than 175. So that is 50. So what's 50 divided by 15? That is 3.3. I mean, we're not going to go up in 3.3s per square. That would be crazy. So again, we'll just go up in fives, and we'll start at 120. Okay, so actually we'll start on 120, going up in fives. So similar scale: 130, 140, 150, 160, 170, 180, 190, 195, and the maximum was, yeah, that include, our maximum will fit in there. So kind of run out of space here, so this is height, and that is centimeters as well. So let's start plotting the values. So 121, 125, 121, 125, 121, 125, so I'll just put a dot there, or an X, doesn't really matter. 140, 136, 140, 136, so there. 132, 140, 132, 140. Sorry, this is a bit slow and boring, isn't it? 150, 150. That should be nice and easy, that one. So 150, 150. 56, 64. So 56, 60, 1, 2, 3, 4. We'll stick that one there. 68, 62. Sorry, I appreciate this is really boring. 68, 62. I think that's right. Yeah, looks good. 63, 70. Only 3 more to go. 80, 75. 80, 75 is there. 42, 40. 42, 40, and the final one, 62, 59. Okay, 62, 62, 59. Okay, right, so describe the correlation. So what I'm going to do for this is I'm going to put in a line of best fit. Now the line of best fit is going to go right through the centre of these data points, trying to keep more or less the same number above and below the line. So for example, this would be a terrible line of best fit, as it's not steep enough. This one is far too steep, so you want something that kind of goes through the middle like so. Maybe pull that down a little bit. It's the sort of thing I could ask 10 students to do a line of best fit and they'd have 10 slightly different lines, but they might all be equally valid. Now the fact that we can draw a line of best fit, you can see that the dots are all relatively close to the line. That proves that there is correlation. And because the line is going up, then we can say that the correlation is positive. So positive correlation, And in the context of the question, that means as your arm span increases, so does your height. Okay, question number 12. Okay, so what we need to do is we know that the record for the distance travelled in an hour is this. So that means the average speed was 53.731 kilometres per hour. So we want to work out the average speed that Harry's cycling at. Now the speed is the distance divided by the time. So the distance is 41.829 divided by 47.75 minutes. Because this is kilometres and this is minutes, my speed is going to be in kilometres per minute, and that comes to 0.876 kilometres per minute. So if in 1 minute Harry does 0.876 kilometres, then in 1 hour he'll do 0.876 times by 60, and 0.876 times 60 is 52.56 kilometres per hour. So that is a lower average speed than for the world record. So could Harry beat the record? Unfortunately, the answer is no. Okay, so what we need to focus on first of all is that 3/5 is 321.45. So what is 5/5 when 3/5 is 321.45? Well, what I'm going to do is work out what 1/5 is. Now 1/5 is going to be it's 3 times less than 3/5. So that's going to be 321.45 divided by 3, which is 107.15. So therefore 5/5, well, that is 5 times more. So that's going to be 107.15 times by 5, and that comes to £535.75. Now the company is increasing the total by a rather bizarre amount, 23.2%. Now the multiplier for 23.2% is 0.232. So this is the multiplier we would use to calculate 23.2%, but when we want to increase by 23.2%, we're going to add 1 to this figure, so we're going to multiply by 1.232. So my final calculation is 535.75 times 1.232, and we get our final answer of £660 and 044. We'll round to 2 decimal places, and that will just round down to £660 and 4p. Okay, so on to question number 14. So we want to work out the range for B first of all. So the range is the biggest value, take away the smallest. Now the biggest, 51, anything bigger than 51, 57, 59, so 59, take away the smallest, anything less than 29, nope, so the range is 30. So Team B has got a smaller range than Team A. We'll worry about what that actually means in a moment. For the mean, we just need to add up all of these values and divide by 10, because there are 10 values. That adds up to 417. 417 divided by 10 is 41.7. The coach of Team A says Team A scored more goals on average. Okay, that's correct. So we can say Team A scored more goals on average as the mean was higher. And what's all this about consistency? Okay, well, consistency is related to the range. The greater the range, the less consistent. So there is a greater range, so that means there's a greater variation in the value, so therefore Team A was less consistent. So we can say Team A had less consistent goal scorers, as the range was greater than Team B. So yeah, always think about consistency and range being linked. The bigger the range, the less consistent. The smaller the range, the more consistent. Question number 15, in my opinion, is a bit of a dodgy question. So what we know, we want to work out it's an estimate for the mean, and the reason why it's an estimate is because let's take a look at the top row. We've got 40 phone calls, and we don't know if they were how long they were. We just know they were somewhere between 0 and 2 minutes. So they could all have been 0 minutes, or they could all have been 2 minutes. So what we're going to do, we are going to assume that they were all the midpoint of 0 and 2, which is 1. And the only reason I think this is a dodgy question is because we're dealing with time here. It's not like we're dealing with the number of goals scored or something like that. Is, well, what do you do with a call that was 2 minutes 30? It doesn't really fall in any range, any of these ranges here. Anyway, we'll ignore that. 3 to 5, the midpoint is 4, 7, 10 and 13. So the mean length of a call is going to be the total length of all the calls combined divided by the number of calls. So I'll just write that down, number of calls. Now here, instead of the total length of the calls, it's going to be an estimated total. So we've got 40 phone calls that we think were 1 minute each. So that is a total of 40 minutes. So here we're going to create another column which is frequency times the midpoint. So we're going to do multiplication across all these rows here, and that will give us 128, 210, 250 and 260, giving us a total of 888. So the estimated total is 888 divided by, well, how many calls were there, so we need to add up the frequency row as well. That comes to 147. So 888 divided by 147 is 6.0408, and that doesn't tell us how many decimal places, so we'll just leave it like that, 6.0408 minutes. Okay, so Tyler is driving from London to Plymouth. So we've got a distance chart here. So London is here, Plymouth is here. Where do they coincide? It's at this point here, 214. We can also do it the other way around. Plymouth to London, it's still 214. So that is 214 miles. Okay, so it's 214 miles and it's 32.1 miles to the gallon. So how many gallons of petrol will this person use? I'll do all the workings here just so that I'm not scrolling up and down the whole time. So that is 214 divided by 32.1, and that is 6.6 recurring gallons. Now we know that 1 gallon is 3.785 litres, so here we just need to do 6.6 recurring multiplied by 3.785 to turn the gallons into litres, and that is 25.23 recurring litres. Now we've been told that a litre of petrol costs 128.5 pence back in the good old days. 25.23 multiplied by 128.5, that is 3242.483 recurring, and remember that this is pence, so turning this into pounds, that is going to be £32.42483. So we'll call it, as it's a price, we'll round to 2 decimal places, so £32.42. So we've worked out the petrol cost, and we want to work out how long it's going to take. So we know that the speed is the distance divided by the time. Now whenever you've got a formula where something equals a fraction, you can just flip these things around. So time is the distance divided by the speed. Now the distance was 214 and the speed was 40. So that is 214 divided by 40, and that is 5.35 hours. It does say hours and minutes. Now I know a lot of people will simply write down 5 hours 35 minutes, but what if your calculator had said 5.95? You wouldn't write 5 hours 95 minutes, because 95 is more than an hour. So your calculator doesn't know you're doing time. Your calculator works in a decimal system and time counts in 60s, which makes this a bit annoying. Well, we know it's 5 hours anyway. And then we've got this 0.35 of an hour. Now an hour is 60, so we know that this is less than a full hour, so let's turn an hour into something less than a unit that is less than an hour, so minutes. So 60 minutes. So what is remember 0.35 is 35/100ths, So we're just working out 35/100ths of an hour or 35/100ths of 60. Either of these calculations works. So 60 divided by 100 times 35, or 0.35 times by 60, and that is 21 minutes. So a lot of people will definitely get that last bit wrong, that's for sure. So question number 17, so we're investing £14,000, let's just make a note of that. So in Saver 1, just write S1, it's going to increase by 3% per year. Now the multiplier for 3% is 0.03, but when we want to increase by 3%, we add 1 to this figure, so it's 1.03. So it's going to be 14,000 multiplied by 1.03, and it's 2 years, so we'll multiply by 1.03 twice, or 1.03 squared, and that comes to £14,852.60. Now Saver 2, similar calculations, so it's going to be 14,000. The multiplier for 5.3% is 0.053. It's always, if it's single figures and got a decimal, it's easy to get them wrong, so just divide them by 100. But we want to increase, so it's going to be 1.053, and 0.9 be 0.009, not 0.09. So to increase, it's going to be 1.009. So 14,000 times by 1.053 times by 1.009, and that comes to 14874.678. So we can see that this is greater than this amount here, so therefore the answer is Saver 2. Okay, question number 18. So the accommodation is £142 per week. So for 30 weeks, it's 142 times by 30, and that is 4,260. And what fraction of the student loan is this? So the fraction is 4260 over 12780. Now there's a few things you can do here. You might have a calculator where you can just type this in as a fraction, or do 4260 divided by 12780, and your calculator will hopefully just tell you that that is 1/3. You could try simplifying it yourself. So first of all, 4260 over 12780, just chop off the zeros, we've divided by 10. We've got two even numbers, so we can divide by 2, so that is 213 over 639. But we're sort of struggling now. We're just guessing maybe we can divide them both by 3, and you'll find you can actually divide them by 3, so 71 over 213. But now we're really struggling. 71, well, what goes into 71? Well, the only thing that goes into 71 is 71, and 213 can be divided by 71, but I don't expect you to be going through all the prime numbers until 71. Again, at this stage, I mean, just divide 71 by 213 and you'll get 0.3 recurring, which is 1/3. But if you're doing that, you might as well have done it right at the start. 4260 divided by 12780, your calculator will probably say 1/3. If not, it will say 0.33333, and you just need to recognise that that is the same as 1/3. So the final answer is 1/3. Question number 19. So we're just using the formula. So remember, 27D means 27 times by D plus 0.2m, which is 0.2 times by m. So that's 27 times by 8 plus 0.2 times by 378. Your calculator should be able to cope if you just type it in like this. It will automatically do the multiplication before it does the adding. But remember, BIDMAS, you do the multiplication first. So 27 times 8 is 216. As I say, your calculator will automatically do BIDMAS. 0.2 times by 378 is 75.6, and 216 plus 75.6 is 291.6. So in other words, the cost is £291.60, which is less than 300. So will this cover the cost of the car hire? So yes. Okay, question number 20. It's another one doing BIDMAS. So just think about our BIDMAS. The first thing we need to sort out is the brackets. So inside the brackets it's 45 divided by 5 times by 3. We'll do the division before the multiplying. 45 divided by 5 is 9, 9 times 3 is 27. So we've got 92 brackets 27 plus 32, and this means 92 times by 27 plus 32. 92 times by 27, do the multiplying before we do the adding. 92 times by 27 is 2484 plus the 32, and that comes to a total of 2516. Okay, so the question is asking for the percentage difference between the median weight of the fish Rona caught. So we want to calculate the median, which is the middle value when you put them all in order. So let's put these in order. So we've got 4, 3, 5, 6. The next smallest is the 4803, then 4851, and 4913, 4985. So the one in the middle, well, we'll find by chopping off the edges and going. So the median weight is 48, I can't read my writing, oh that's 51, and that is grams. Okay, now we're comparing this to 10.8 pounds. So okay, well we've got two options. We can either convert this into pounds, or we can convert 10.8 pounds into kilos. First of all, we want to turn this into kilos, so that is 4.851 kilos, just dividing by 1,000. So if 1 pound is 0.454 kg, then 10.8 pounds is 10.8 multiplied by 0.454, and 10.8 multiplied by 0.454 is 4.9032 kilos. Okay, so you want the percentage difference. So it's so what is the difference? Well, the difference is 4.9032 take away 4.851, and that comes to 0.0522 grams. Okay, so we're working this out as a percentage of what? Okay, to me it's not really obvious whether we're working this out as a percentage of the heaviest fish caught or the median weight. I think because it says the percentage difference between, and the first thing that's mentioned is the median weight, let's go with the median weight, which was 4.851. I think they could have been clearer on that. So 0.0522, what is that as a percentage of 4.851? So what I've done is we've got a fraction here, and to convert a fraction into a percentage, it's just the top divided by the bottom times by 100. So 0.0522 divided by 4.851 times by 100. So again, obviously this is a calculator job, and we get, it's not a particularly nice number, we get 1.0760679%. Any indication as to how they want the answer presented? Well, we could just say which is, well, we could say 1.08 to 2 decimal places. Okay, and that is the end of the assessment.